students, I am Meenakshi from Rohini College of Engineering and Technology. Today we are going to see the topic ElGamal crypto system. So ElGamal crypto system is introduced in the year 1984 and it is again the public key scheme. It is based on discrete logarithm. It is very much similar to Diffie-Hellman technique. So we have two schemes, the ElGamal encryption scheme and the other one is ElGamal signature scheme. So in ElGamal encryption scheme, for encryption you have to use user's public key and for decryption you have to use user's private key. Whereas in ElGamal signature scheme, for encryption you have to use the sender's private key and for decryption you have to use the public key. And this ElGamal crypto system is used in combination with some other standards like digital signature standard, SBAR-MIME email standard and so on. So very similar to Diffie-Hellman, in ElGamal crypto system also we need some global parameters, that is the prime number Q and the primitive root A. The security of the ElGamal crypto system is fully based on the difficulty of computing discrete logarithm as like as RSA, DSA. Here also the security depends on the difficulty of computing discrete logarithm. So we move on to the algorithm, ElGamal digital signature. So here each user generates their key. So he chooses a random key that is denoted as XA and this random secret key should lies between 1 to Q minus 1 where Q is a prime number. So after that he or she has to calculate the public key. So the formula for calculating the public key is YA equal to A power XA modulus Q. So this is very similar to Diffie-Hellman. YA equal to alpha power XA modulus Q, where alpha is the primitive root. So instead of alpha here we have taken it as A. So ElGamal digital signature. Alice is the sender. Alice signs a message M to Bob. First she has to calculate the hash of M. From the message she has to calculate height of M, that is hash of M, and usually M also lies between 0 to Q minus 1 and she has to choose one random number K. K also lies between 1 to Q minus 1. The GCD, that is the greatest common divisor between the K and Q minus 1 should be equal to 1. Then she has to calculate two signature components S1 and S2. So S1 formula is A power K modulus Q and for S2 the formula is K inverse M minus XA into S1 modulus Q minus 1. Thus we have the signature which consists of two components S1 and S2 and it is transmitted to the receiver. At the receiver end, we can verify the signature by computing the two components V1 and V2. So formula for V1 is A power M modulus Q and V2 is YA power S1, S1 power S2 modulus Q. If V1 is equal to V2, then we can say that the signature is valid. We move on to one example, then you can clearly understand. ElGamal signature example. So we have taken the prime number Q as 19 and the primitive root A as 10. Okay. So Alice can choose her private key XA, it is equal to 16. It should lies between 1 to 19. Okay, so she chooses her private key as 16 and from using private key she calculates her public key. The formula for calculating public key is YA equal to A power XA modulus Q. So what is the value of A? It is 10 and XA is 16. modulus q is 19. Okay, so to calculate 10 power 16, we can use modular arithmetic properties. So that is, you can split like this: 10 power 4, 10 power 4, 10 power 8. So 8 plus 4, 12, 12 plus 4, 16. Okay, so what is the value of 10 power 4 modulus 19? So 10 power 4 modulus 19. So you can use calculator to calculate 10 power 4 modulus 19. So we get 6 as the answer. So 6 into 6, that is 10 power 4 into 10 power 4 modulus 19. So that is 36 modulus 19. So we get the answer as 17. So now we have completed this part. So 17 into again 10 power 8. So 17 into 17 modulus 19. So answer is 4. So the final answer is 4. Okay, so once again. So to calculate 10 power 16 modulus 19, we have splitted like this: 10 power 4, 10 power 4, 10 power 8 modulus 19. So 10 power 4, use your calculator, we will get the answer as 6. So 6 into 6. Okay, so again it can also be divided into 6 into 6, or otherwise you can solve this: 36 modulus 19. We get the answer as 17. Okay, so this 17 into again 10 power 8, it is also 17 modulus 19. Okay, so we get, you can use the calculator and you get the answer as 4. So this is the public key of Alice. So now we are creating the signature component S1 and S2. So already we have discussed about the formula. We have the message m equal to 14. Okay, and Alice chooses the random key as 5. And what is the condition? GCD of k and q minus 1, it should be equal to 1. So such that we have chosen one random key, it is 5. And the formula for calculating S1. So the formula for calculating S1 is a power k modulus q. A power k modulus q. Okay, so this is the formula. So a is 10, k is 5, modulus 19. Again you can apply the modular arithmetic. You can divide the problem into 10 power 4 into 10 power 1. So 10 power 1, 10 power 4, we have already calculated the answer as 6. So 6 into 60 modulus 19. We will get the answer as 3. Okay. So then to calculate the second signature component, we have the formula S2 equal to K inverse M minus XA into S1. So this is the formula. So K inverse, K value is 5. So we have to calculate 5 inverse modulus 18 equal to 11. So refer RSA algorithm. So where I have instructed how to calculate the inverse. So we have calculated the inverse, its value is 11. So K inverse is 11 and M is 14. XA, that is the private key, what we have chosen is 16 and S1 is 3. Okay, so again we have applied the modulus operation. So we get the answer as 4. So S1 equal to 3 and S2 equal to 4. Okay, so that is the signature component consists of two components, S1 and S2. S1 value is 3 and S2 value is 4. So all are transmitted to the receiver. At the receiver end, they can verify the signature. So again they have to calculate the component V1 and V2. Okay, so what is the formula for V1? V1 is a power m modulus q. And what is V2? Ya power s1, s1 power s2 modulus q. Okay, so apply the formula. V1 is a power m modulus q. So a is 10 and m is 14, modulus q is 19. Okay, again you can use a modular arithmetic. We can divide the problem into 10 power 4, 10 power 4, 10 power 4. So that is 12 into 10 power 2. So anyway you can split the problem into sub problem and you can combine the solution. So we will get the answer as 16. The formula for V2 is Ya power s1, s1 power s2 modulus q. Okay, so Ya in the first step we have calculated Ya as 4 and s1 the first signature component, it is 3, into the signature component, the first component is 3 power 4 modulus 19. So you can use your calculator. And now the values of V1 and V2 are equal. Thus we have proved that the signature is valid. Okay, so that's about ElGamal crypto system. So to solve the problem you have to know how to apply the modular arithmetic concepts and how can we calculate the inverse value. Thank you all.